Welcome to lesson 2.2.1's review and preview for day 2 and day 3. There's a lot of different problems and a lot of different scenarios to cover, so let's just jump right in. Okay, so 2-88, Lilia wants to have a circular pool put in her backyard. Boy, would I love a circular pool put in my backyard, but I couldn't. We wouldn't be able to fit one in there. She wants the rest of the yard to be paved with concrete. If her yard is 50 by 30 feet rectangle, what is the radius of the largest pool that will fit in her yard? So you can see that we have a rectangle and we have a circle inscribed into the middle of that rectangle. And so if you're looking at the width or the height, however you want to say it, right here, that is going to be 30 feet. So that means our radius has to be half of that. So our radius is 15 feet. So we'll just answer that right here. Okay, then it says, if the concrete is to be 8 inches thick and cost $2.39 per cubic foot, what is the cost of putting in the concrete? No concrete will be used in the pool. And then a reminder as to what the volume of this shape would be, base times height times depth. So on the first thing we're going to do is we're going to take and find the area of the circle. Well, the area of a circle equals pi r squared. Okay, so our area equals pi times 15 squared. So that's going to equal 225 pi feet squared. Okay, that's the first part. Then we need to find the rectangle. Well, the rectangle is just, so area of the rectangle is just length times width. So that will equal 30 or 50. Let's do that times 30. So the area for this is 1,500 feet squared. Okay. So what we're going to have to do is subtract 1,500 feet squared plus minus 225 feet squared, or 225 pi feet squared. And when you do that, 1,500 minus 225 pi, and you can check this out on the calculator, is actually 793.14 feet squared. So that's the surface area of what we need actually calculated. Now, it also says that it's 8 inches thick, and we're dealing in feet. So that means we have to figure out what is 8 inches. Well, 8 inches is 2/3 of a foot. So we're going to be multiplying 793.14 times the fraction, let's just do this, of 2/3. This will give us the volume of everything that we need to multiply by $2.39 to find out how many cubic feet of concrete are going to be needed. And so when I do 793.14 times 2/3, I get, what am I putting a dollar sign there for? Not yet. We haven't multiplied that by 239 yet. It's 528.76 feet cubed. Okay. And now I'll just come up here, since we have a little more room, I'll come up here for the final part of the equation. So I'm going to multiply 528.76 times $2.39, and that will give us a final total of $1,263.74. So there's a lot of things to keep in mind when you're doing this. Obviously, the area formulas are really, really important, but it's also important that you know that you're using the right unit of measurement against another unit of measurement. I think a common mistake on this problem would be for people to multiply this 793.14 times 8. That would be crazy. And so that's not what you want to do. And then multiply that by $2.39. And honestly, that would be an extremely expensive backyard to put concrete in. So just make sure that you are comparing units to units. So because they gave us the depth as 8 inches, but everything else is in feet. You've got to convert that 8 inches to feet, and that's why we multiplied by 2/3. Hopefully that helps, and we're moving on. Okay, on 2-89, a line with a slope of 3 and a y-intercept at 0, 2. You've got some things you got to do here. Sketch the graph of a line, write the equation of the line, and then find the initial term and next 3 terms of a certain sequence, and explain those similarities and differences between the graphs and equations. You can see I have a graph of the line right here, but we're going to actually pop a video in here and use the e-tool from Desmos to help explain what is going on here. Okay, on 2-89, it says consider a line with a slope of 3 and a y-intercept of 0, 2. So I'm also going to plot the point of 0, 2, so we have that on our diagram. And I'm going to label it as the y-intercept. Okay, so I have that now. So sketch the graph of this line. Hint, drag the points on the blue line. Okay, well, I'm going to go ahead and do that. I'll take this to this part, okay? And then it's going up 3 over 1. So that's my line. So now I got to come up with my equation, all right? But we really didn't even need that blue line for this equation. But it's nice that we have an e-tool that helps us do that. So we know that our slope is 3, so it's going to be 3x. And then we also know that it's at a y-intercept of 0, 2, so it's going to be plus 2, okay? So there's the line for that one. All right, and you notice we actually graphed it correctly with the blue, and it confirmed with the red. Now, the next one, it says, find the initial term and the next 3 terms of the sequence, t of n equals 3n minus 1. And you can see they already have 1 point here at 0, negative 1. Well, the next 3 would be 1, and this table will fill them out for us. Okay. Then it says, explain the similarities and differences between the graphs and equations in parts A through C. Are both continuous? Well, if you look at the equations are both linear. They're both in y equals mx plus b form. But this is a sequence of things that are allowed to be in this particular group. So it's not an actual line, okay? This line is continuous. This goes on into infinity, positive and negative, to positive and negative infinity, obviously in both directions, all right? So what we would say is this particular graph, and this is answering part D, explain the similarities and differences. Similarities is they look linear. Differences are that y equals 3x plus 2 is continuous, and this part C is discrete. It's only for a certain number of points, and that's all they've asked us for in that particular graph. Notice it's all set up here as points. If I wanted, I could go ahead and change that to lines. Let's see. And it would give us a line, but it's not asking us to do that. So we're going to get rid of the line, and it's discrete, okay? And that's pretty much all you're doing on 2-89. Okay, and then moving on. Okay, 2-90, the gross national product of the U.S. in 1960 was 1.665 times 10 to the 12th. That's in scientific notation, of course, dollars. Until 1989, it increased at a rate of 3.17% per year. Use this information to answer each of the questions below. So our starting point for this equation would be 1.665 times 10 to the 12th. But then we have a growth of 0.0317 because that's 3.17%. So this is our multiplier times 1 plus 0.0317. But it's over the course of 29 years because that's our time, that's the amount of time we're talking about. So when you do that in the calculator, you will get this amount, but some of you will also get a gross national product in scientific notation, which would be 4.116 times 10 to the 12th dollars. And that was in 1989. But then that also helps us with the equation. So the only thing that changes from here to here as far as the equation is that now instead of 29, we put a variable for t, and this would show exponential growth, okay? Now, it does say in number 3, do you think the rate of growth really remains constant? Well, if you look at the wording of the question, it says until 1989, it increased at a rate of 3.17% per year. So it was constant from 1960 to 1989. But that we don't know. I mean, we could look it up, but we don't know what the GMP was for 1990. And just with the economic situations of our world, It's not always easy to predict. And so it can be constant for a while, but there are things that disrupt it. So it's not necessarily something that you can bank on forever. But it is something you can pay attention to, especially as you watch the way the world economy goes. So that answers the question for 2-90. So many of these slides, I'm going to go ahead and I've already done the work, and I'm just going to go over them with you. So on this very first one, on 2-91 on A, I'm just combining like terms. So I'm adding the A plus the square root of X to the 5 root X. And that gives me the 6 root X. Then I'm adding the root Y to the 2 root Y. And because you can't do anything with them, it's not like root Y plus Y. It's not going to happen. So then it's plus 3 root Y. It's kind of like adding an X and a Y and a Y. You can do that, but you can't add an X and a Y. Okay, so this is the final answer for that problem. Part B, what I did is I distributed this 2 to the 2 and to the 8. So you can see this here. 2 squared is 4. And then root 2, so root 8 squared is 8. So then 4 times 8 is 32, which you see here, okay? On C, what I did is I simplified the top, and you can see that from the fact that I have broken it up into the highest perfect square that goes into 50 is 25, so it's square root of 25 times 2. That square root of 25 comes down here and is 5, and then what's left under the radical is root 2. But then it's over root 2. And so you can cancel those out. So that's why it equals 5. Part D, all I did was rewrite it as the square root of 3 over the square root of 4. Well, the square root of 4 is 2. So that simplifies that problem pretty easily. Yeah. Okay, you get what I'm saying. All right, moving on. Okay, so on 2-92, I'm just distributing this term to both of these terms. And I have to remember that when I have the same base as I do with the x's, I am adding when I multiply. So like 2x squared times 3x is going to be 2 times 3 is 6. But x squared times x to the 1 is like x to the third, okay? And then the same thing when I multiply it by the second term. 2 times 4 is 8. And then x squared times x squared is x to the fourth, because you're adding the exponents when you multiply with the same base. And then there is no other y, so it's just y by itself. So this is the answer for that particular one. On part B, you see I distributed the 4 to the 3 to get the 12. And I distributed the 4 to the 2 to get the 8. And then all I'm doing is multiplying the x to the 12th times x squared, and that's why I get x to the 14th. Then I'm multiplying y to the 8th times y to the 1. And so I get y to the 9th. And so it's x to the 14th, y to the 9th. And that ends 2-92. Okay, on this problem, you have a graph, which I've done here by putting in a graph for you. But if you look at it, y equals 2 times x minus 4 squared minus 3 is in graphing form. So this determines our x. So our x is going to be 4. And our y is going to equal, that's not very neat. That's our vertex. So our vertex is 4, -3. And you can see that right here, okay? Now, I have said in the past in other videos that the y determines the max or the minimum. And in this case, because the parabola opens up, our y value is a minimum, okay? And then this determines the axis of symmetry. Okay, so my equation is going to be a vertical line, and I'm going to go ahead and draw that. And it's going to go through the point x equals 4, which is right here. So our equation for that is x, let me get the pen, x equals 4. And that ends 2-93. Okay, so sometimes it takes longer to read the word problems than it actually does to solve them. But let's just go through this really quick. I'll let you read through the whole scenario, but basically we're talking about cylinders for propane gas and how they're like a cylinder with 2 hemispheres, a hemisphere on each end, so they're rounded. And so they want us to calculate a couple different equations with different radiuses, yeah, whatever, you know what I'm talking about. Okay. And they've given us the volume for a sphere, but I also wrote down the volume for a cylinder in case you have not remembered that. And basically, we just need to go through and calculate what we have. So on problem number 1, It says one of the tank models has a radius of 1 meter. Well, that's kind of easy when you plug in the information to the formula. So we've got a 4/3 times pi times 1 cubed. Well, that's just 4/3 pi, which you'll see down here, kind of important. And then on the cylinder, you have pi times the radius squared, which is 1 times 4. So it's 4 pi, and that's here. So basically, all you're doing, and you notice they said 2 half spheres. Well, that's a whole sphere. So we just need to do the volume of a sphere and a volume of a cylinder and add them together. And so if you're leaving it in terms of pi, you would have to give a different answer. But if you're rounding it to nearest thousandths, it would be 16.75 meter. Sorry, I am not editing this out. I just want you to know I make mistakes. 16.755 meters cubed. Okay, that's the answer for part 1. Now, the question on part 2, it says if the radius is doubled, will the volume double? No, you can't say that because in the sphere formula, we are using our radius and cubing it. In the cylinder formula, we are using radius and we're just squaring it. So that can't be just a double just because we decided to put 2 in there. All right, so let's actually calculate the one with 2 meters as a radius. All right, we have 4/3 pi, and then 2 cubed is 8. So I just take the 8 and multiply it times the 4. So I've got 32 pi over 3 here. On the cylinder, we have 2, we've got our radius, and then 2 squared. So that's 4 times 4, so it's 16 pi is our final answer on that one. Now, if we're doing the total volume, we can add those. But if we're trying to add them in terms of pi, you're going to have to change 16 pi to 48 pi over 3 so you can have a common denominator. And that would equal 80 pi over 3 or 83.776 meters cubed. Now, basically what we've come up with, because it says on part 3, what's the equation? Well, all the equation is calculating the area, or the volume for the cylinder and the volume for a sphere. And they've given us the height of 4. So that's the only thing that's not changing because the radius is what's going to change based on the sizes of the propane tanks they have. So our rule is just 4/3 pi r cubed, which is representing the sphere part, and 4 pi r squared, which is representing the cylinder. When you get that, you have the volume of any tank that you want to work with. So, all right, that's all we got there, and we're moving on. Okay, so we have 9 graphs here, and it says write a possible equation for each of these graphs. Assume that 1 mark on each axis is 1 unit. When you are in class, check your equations on a graphing calculator, compare your results with your teammates. You don't even have to do that. You can get on Desmos and check them out, but the next slide will have a video that helps you with all 9 of these graphs. So moving on. Okay, so on 2-95, they have like 8 graphs, and they want you to come up with a function or an actual function with the translations in it. Now, the one thing you need to know is that there are probably many different equations you could do, but we're going to go with the simplest for each one. So on graph A, this is what it looks like. And it looks like a reciprocal function to me, which some call inverse linear as well. And what I'm going to go ahead and do is type in our reciprocal function. So y equals, and it's just 1 over x, okay? And that's the equation that we would have for our parent function. That's the orange. Now, it looks to me like this is shifted 2 to the left. So that's a horizontal translation. And so that means I'm going to need to put a +2 because it's going in the opposite direction. And you'll notice how it just coincided with the graph we had because there's no vertical translation on that one. And so that is the answer for the first one. That's part A. Okay, let's mute both of those. Okay, so those are muted. And now here's part B. Part B looks like a quadratic that has had a vertical translation, and it looks to me like it has gone down 5. I'm going to do something here because I like to be able to see grid for grid. There we go. Looks like it's gone down 5. So typically I would do y equals x squared, right? For a parabola. But it looks like this one is shifted down. It's not a horizontal translation. So all I have to do on this one is type -5 because there's no horizontal translation. And you notice how it coincides now. If I mute, that's the original, and this is our new equation. So that works perfectly. All right, let's move on to part C. Okay, so part C looks like a cubic function that has moved to the right. And so typically, let's go to C and type in y equals x cubed. All right, there's our cubic function, our cubic parent function. This is moved to the right, so we're going to need some parentheses here because this is a horizontal. So I'm going to put parentheses here and then parentheses here. And what goes inside it, since I'm moving to the right, is minus. Remember, we have to think of it as minus h. We're plugging in 3, so it's going to be minus 3. And notice how that coincides now. And so we've figured out an equation for part C. All right, moving on. Okay, so part D here looks like an exponential growth equation. So I'm going to go ahead, and we don't know exactly what A is, and that's what we have to do because X is our exponent, that's our variable. So I'm just going to type in y equals B to the X, and it'll give me a slider for B. And I'm going to kind of play with it a little bit and see, oh wait, what am I missing here? Oh yeah, because it's 1. Hang on. I want to get to the like similar shape. Okay, I'm going to go with 2. I'm going to try to see if this is 2. So let's go up here. I'm going to go ahead and get rid of the, well, I won't get rid of it yet. We'll just do 2. All right, 2 to the x. Okay, good. I'm kind of liking that. Now, it also looks like it is a shift down of 3. So again, this is not horizontal, so we don't have to do anything minus or plus on the x. So we're going to do a minus 3 and see what happens if they coincide. Perfect. So that one's a little trickier because your A could be all kinds of things. So just add that slider in there and you can play a little bit with it. All right, so that closes out part D. Let's move on. Okay, so this is linear. At least it looks linear to me. So if I go in here, our linear parent function would be y equals x, okay? There's a couple things I know here. I have a -6 as the shift down, so I have a -6, but now I need to figure out what is their slope, so their A, so to speak. 1, 2, 3, it looks like 3. So I'm gonna go ahead and type in 3 out here, okay? And then we're going to go ahead and just do -6. So this was pretty simple because it was just a linear equation and they do coincide. So let's move to the next one. This looks like a cubic function to me, and it looks like it's not only got a horizontal change, but it looks like it has a vertical change as well. So let's put the parent function in. All right, y equals x cubed. Okay, very good. All right, and so it looks to me like it's got a shift. So I'm going to start the parent function. Let's do this. Okay. I'm going to put x in. And I see that it's going to the left. So I'm going to go ahead and put +2. Because remember, we have to think opposite. Okay, so far I think I'm doing okay. And then outside here, looks like I have a vertical shift up of 3. So I'm going to do +3. And it looks like it coincides. So we're doing good. And that is a perfect equation for that one. So let's go to the next one. Okay, again, this looks like a quadratic with not just one sort of translation. It looks like we're going to the left and we're going down vertically. So I'm going to go ahead and start with y equals, and we're going to put parentheses around it because we know we're going to have a change. And since it's going to be a positive, it's going to the left, it's going to be a plus, and I think it's 3. Okay, so we're going to start there. And I got to remember that I got to square it so that our line doesn't keep showing up there. All right, that's good. But now I have to come down here and I have to figure out, it looks like it shifts down 6. So that's just -6. All right, we're getting close. We only have 2 more left. So here we go. I'm going to mute this and move to the next one. Okay, again, we have a few things going on here, and I'm hoping you're finding this out. Looks like we have a -a because it's opening downward. So I'm going to go y equals, and I'm going to put a negative in front in case we don't know. We might have to, well, actually, I'm going to start with the parent function again. So x squared. All right. Let's put a negative in front of that. So we know we're going in the right direction. Okay, very good. And it looks like it shifts 3 to the right. So we'll put parentheses and we'll do, oops, that's not where I wanted that. Okay. Let's go over here. Okay. X -3. Okay. and then parentheses. Awesome. And then we have to go over here and put in plus, and it looks like it goes up 6. So I'm going to put plus 6. And it's not graphing because I have it muted. So let's take a look. No, I just want it to be a color. There we go. Okay, so you didn't get to see all of that. So let's go back to taking off the 6. Okay, and let's take off the 3. All right, and we'll take that. So this is where we were. So now I'm just going to go ahead and put my minus 3 in because we're going to the right. Minus 3. Then I'll come out here and I'll do plus 6. Okay. Sorry about that. You didn't get to see all that because I had it muted. And you'll see that they coincide now, so they are agreeing with each other. So let me mute those and we'll do the last one. Okay, so this is our last one. And this one looks like a cubic function that has moved left 3 and down 2. So I'm going to go ahead and start typing in that equation. We're going to go y equals. And remember, we have to put in parentheses. So if we're going 3 to the left, it's going to be x plus 3. And then we've got, of course, cube it. Then we've got a shift down 2. So it's just going to be minus 2. All right, you see how they coincide? So let's just take a look if you want. You can go back and rewind this a little bit. But here you go. You've got your example equations for all of the problems on that particular problem on 2-95. Now, one thing I want to point out, this is an e-tool. So if you want to go back and review, you can go ahead and go back and review and do these on your own as well and just check them. But that's all there is to this problem. And I know it was a long one, but they gave us a lot of graphs. All right, take care. Moving on. Okay, on 2-96, it says, by mistake, Jim graphed y equals 3, or x to the third minus 4x. That is what you see here. And then instead of y equals x cubed minus 4x plus 6. And it says, what should he do to his graph to correct it? All you have to do is translate your graph up 6 units for each of the points on your graph. And that's pretty simple to do. But that's all there is to 2-96. Moving on. Okay, here it says simplify each radical expression. So again, just like I did on the other problem, I distributed my 2 here because that's just the way I see it is easier. So I have 3 squared and root 2 squared. Well, that's 9 times 2, which gives me 18. Okay, so that's all there is to that one. Also on B, I just split it up just like I did on the last one where I made it square root of 9 over square root of 4. Well, they're both perfect squares, so they just changed to 3 over 2 because the square root of 9 is 3, square root of 4 is 2. Okay. Part C, you may not have done a lot of rationalizing of the denominator, but again, I broke it down to square root of 1 over the square root of 3, which the square root of 1 is 1. So I've got that here, but I have to rationalize the denominator because I can't have a radical in the denominator. So I multiply it by the value of 1, but as square root of 3 over square root of 3. So then when I do the 1 times root 3, it equals root 3. And when I do root 3 times root 3, it equals 3. So hopefully that helps because this is the final answer on that one. All right. On part D, you'll see that I foiled these. So first of all, I wrote it out as 3 plus root 2 times 3 plus root 2 because I think a lot of students forget that they need to do that because you would have a middle term. And then I do my first terms, which is 9. I do my outside terms, which is 3 times root 2, so that's there. And then I do my inner terms, and that's here. And then I do my last terms, root 2 times root 2, which is 2. And then I'm just combining like terms. So 9 plus 2 is 11, and 3 root 2 plus 3 root 2 is 6 root 2. And that is the final answer for 2-97. Remember, on any of these questions, you can either rewind and listen to the explanation again, or you can leave me questions in my comments, and I'm happy to get back to you. So let's move on to the next one. Okay, one thing you will find on this 2-98 is that I found the difference of perfect squares on all of them. And so if you remember, I'll just write up here an example. If I had x squared minus 4, that's the difference of 2 perfect squares. And that factors to an x plus 2, because you take the square root of each one, to an x minus 2. So on each one of these, I found some sort of difference of perfect squares, except for D, and we'll get there in a moment. Okay, so part A, if you notice, my 4x squared and my 9y squared are perfect squares. So I use the difference of perfect squares similar to what we did above. I do a plus and a minus. So square root of 4x squared is 2x. So I've got 2x and a 2x. Square root of 9y squared is 3y. So I have a 3y and a 3y. So it's 2x plus 3y and 2x minus 3y. And that is all you're doing on A. Now, part B, you've got to do something else first before you can get to the difference of squares. So you'll see on part B, I factored out a 2x cubed, which left me with a 4 minus x to the fourth. Well, that is perfect squares. So if you see below here, my square root of 4 is 2. So I've got a 2 and a 2. And my square root of x to the fourth is x squared and x squared. And then I just have a minus and a plus. And it doesn't matter what order you use them in. So my 2 minus x squared and my 2 plus x squared are the two difference of squares. But don't forget, you can't get rid of the 2x cubed. That's part of the problem, okay? On part C, they are both perfect squares. And we're going to have to do perfect square again when they're done. The square root of x to the fourth is x squared. And the square root of 81y to the fourth is 9y squared, okay? Now, I can't, once I do the minus and the plus, there's nothing I can do with the plus because that would be non-real answers. And we can go into that more later. But neither one of those is going to change. But as you can see here, I have this little note, difference of perfect squares on the x squared minus 9y squared. So I've got the square root of x squared is x and x. And the square root of 9y squared is 3y and 3y. So that's supposed to be a minus in there. So we've got a plus and a minus, and that ends that. This is perfectly factored out, okay? Now, on part D, you do factor out a 2x to the third, just like we did in part B. But the problem is you end up with 4 plus x to the fourth. And if I did x to the fourth plus 4 and set it equal to 0, watch what happens. There's no way I can get a fourth root of a negative number because we're not dealing with imaginary numbers. So this is not a difference of perfect squares, so you just leave it alone. So the answer on that one is just 2x cubed times 4 plus x to the fourth. So the question on part E is, did you use a shortcut to factor the expressions in parts A through C? If so, I think it's funny because they sort of give away the answer that D is not using that hint or that shortcut. If so, describe it. If not, what pattern do you see in these expressions and how can you use that pattern to factor quickly? So what I found in all of them was the perfect square and the difference of perfect squares, except for in part D. And so that's kind of important. So you've got it here, you've got it here, and here. And once you master the difference of perfect squares on all kinds of concepts, your life gets so much easier. So hopefully this helped. And if you've got questions, just leave them for me. Talk to you soon. Moving on. Okay, in 2-99, you'll see that I saw that I started out with a little, kind of a little typo up here. I forgot to put the 3 on there. So anyway, it just wants me to solve for x. So I'm not actually having to find what x is. I mean, the actual number that goes into x and the number that goes into y. So sometimes this can be a little confusing just from that standpoint. But basically, I just want to isolate x. And so the first thing I did was I subtracted by to the third, and you'll see that here. And then, so then that gives me a over x, and then this negative by cubed plus c plus 7. Well, then I divided by a, and then I could cancel it, and then I've got a over here. So that just takes it so that x is now alone, and that's represented by the equation on the right. Okay, that is 2-99, and moving on. Okay, on 2-100, it says write an equation for each of the following sequences. The first one is an arithmetic sequence, and you can tell that because it either adds or subtracts the same amount from each number. So this one is subtracting 6 each time, okay? Then on geometric, so that's kind of like a slope. You're subtracting 6 each time. It's very linear looking. All right, geometric sequence is what happens on the next one because we multiply everything times 4. So let's erase what I just did. So it's like, from here, it's like times 4, okay? Now, on the arithmetic one, you're going to set it up. So if my n minus 1, let's say I was looking at the first element in our thing, which is 20, I would plug in -6 times 1 minus 1 plus 20. Okay, that means negative 6 times 0, which equals 20. And that is our first element of our sequence. So then the next one would be negative 6 times 2 minus 1. So that would give us the 14. Then 3 minus 1, it would give us the 8th. But you can also distribute the negative 6 to both terms, right here and here. And you get this equation down here. Okay, then you combine like terms and you get negative 6 times n plus 26. It kind of looks linear, doesn't it? Now, those are both good. So if I was to do this, both are good. Okay, same thing here. Both are good on this one as well. Okay. And if I'm looking at part B, I've got, if you start with just negative 6, you have to remember that you're putting your one element. It would be negative 6 times 4 to the 1 minus 1. Well, that's negative 6 times 4 to the 0. Well, 4 to the 0 is 1. Okay, so it's just negative 6. That's how you get the first element. Okay, but on this one, they're starting with the one before negative 6 to set up the equation. So if you take negative 6 and divide it by 4, you get a negative 1.5. And then that way you could start with the first one, and then this would be negative 1.5 times 4 to the 1, which would be negative 6. Okay, so it kind of explains how you can distribute. You can set them up a little bit different, whether you do it with the first element or the one prior to it. Just remember what element you're dealing with when you use your n minus 1. Okay, and that ends 2-100. Moving on. Okay, for 2-101, we have two different slides. And again, I've written everything out, and you'll see it on the next slide too. We're going to take care of F and G on the next page. But for I'm sorry, I sketched both functions. You'll see that. This is part A, okay? And you'll see where they intersect at different spots, which we'll talk more about on the next slide as well. Now, on this one, it says solve for f of x equals 9. We could look at f of x and go find 9, and you will. That's similar to what we're going to do on the next page, and x equals 2. But you can solve it algebraically too, which is what I did here. I set 9 equal to x cubed plus 1, solved, and I got x equals 2. And let me erase these little pieces here. Okay. If you see that, one of them is right here. And we're going to prove that again on the other page algebraically as well using systems. Okay, part C, g of x equals 0. If I set them equal to each other, I'm going to take the square root of 2, or the square root of each side, I should say. So that leaves it at 0 equals x plus 1, so x equals negative 1. That means my point is at 0 and negative 1, or negative 1, 0, I should say. And here it is right there, okay? Then on part D, D is square root of 3. Now, we're not going to go ahead and look at this on the graph, but I still set it equal algebraically. Negative 12 equals x cubed plus 1. Then I solve it by subtracting 1, and then I take the cube root of a negative 13, which is totally fine. You can do an odd root of a negative number. You just can't do an even root of a negative number because that's imaginary. So this would leave x equals the cube root of negative 3. Now, that said, if we take and do g of x equals negative 12, we end up, when we take the square root, we can't take the square root of a negative number. That's imaginary. So this is non-real, no real solution for that one. Okay. So now we're going to go to the next slide to talk about f and g's because we have a little bit more room there. So here we go. So this could be a problem where you want to pause it and look through my work or listen to the explanations a little bit more, but you might also have questions later. So let's go ahead and take a look at this. So it says, for how many values of x does f of x equal g of x? Well, the best way and easiest way to do that is to just set them equal to each other, which is what I did right here, okay? And then when you do that, you isolate and you make sure everything moves over to the left or the right, depending on the equation. So I did that where I set everything equals to 0. I factored out an x, and then I had a quadratic, and this should be, if you could see it, it's a 2. Okay. And when I do my diamond method, I get x minus 2 and x plus 1. So here are the zeros that I'm going to test. And a couple of them we already saw on the last page. So what I'm going to do is I'm going to take, because this is pretty easy just to take it from this equation. So I'm going to plug the 0 in for the x. So 0 cubed plus 1 equals 1. So that means my point is 0, 1, which is right here. Then I'm going to go ahead and put a 2 in because that's another one of the ones we have. So 2 to the third is 8 plus 1 is 9. So my point 2, 9. Remember we talked about that on the previous slide. Then I have negative 1 to the third. Well, negative 1 to the third is negative 1. Negative 1 plus 1 is 0. So negative 1, 0 is my other point. That's the three places they intersect. Now, down below on part G, they ask you to find and simplify an expression for f of x minus g of x. And you're going to see something interesting once you do that. F of x minus g of x means we're just subtracting the two functions. So when I do that, I set it up like this. But then I also FOIL out x plus 1 squared. So that gives me all of this on this line. And when I do that, I have to distribute this negative to everything. Now, that's a common mistake. So don't forget that negative goes to everything. And when I do that, I get this line here. And I have to combine like terms. And so when I get done, I get x cubed minus x squared minus 2x. Well, isn't that funny? That's what we got up here when we set them equal to each other. Okay? So it's kind of cool. It's kind of cool that all these different things that we do can come back and verify what we've done before and helps further cement these concepts. So I think this is a cool problem. So if you have any questions, let me know again in the comments. And this is the last problem on review and preview for day 1 and day 2 and day 3. So if you have any questions, please leave them in the comment. If you liked and learned anything in these videos, please subscribe. I'm trying to build my subscribers. And also, please consider giving a thumbs up, okay? And we'll see you on the next video. Thanks a lot. Bye.